Welcome back. We're going to continue our discussion on organic reactions. This time around, I'd like you to introduce the two ideas, even though the second one we're going to look at it a little bit later in the video series. I think it just makes sense to say them at the same time, and also because this video would be about 3 to 4 minutes long, so I think I can say that. So there are two primary types of chemical reactions. One is reduction, and the other is oxidation. Okay, now as I said, what we give on top of the arrows in organic chemistry are called the reagents. Okay, if your reagent, okay, typically the one at the very top of the arrow, if the reagent is hydrogen rich, I'm going to call it hydrogen rich because I don't want to put a specific count as 2, 3, 4. If your reaction is hydrogen rich, then that's reduction. What do you mean is you're adding hydrogen to the reactant to generate a product. You're adding hydrogen to the system, or in this case, the reactant. Oxidation. The reagent itself is oxygen rich. We're particularly keeping our discussion to hydrogen and oxygen only. We can think of other ways. Reduction, which is we can also have electrochemistry down there where it's not necessarily hydrogen, it's electron lost or gained, but we're not going to get in there right now. If your reagent is oxygen rich, then you're adding oxygen. Just that simple. This is the best and simplest way I can explain this. What do you think this is? Is this hydrogen rich or oxygen rich? Now that's what I meant by I will give you this, but you need to know what to do with it. And that's why I'm trying to group them in based on the types of reaction. So they're all within their little family, so you know how that works. All right. So whenever you have again, we're going from alkenes to an alkane. Well, you've learned both. So when you have a hydrogen, all you do is get rid of the double bond and just write it without the double bond. Essentially, why we're doing that is, well, let's rewrite it, actually explain it. We're going to get rid of the double bond, right? We're going to break the double bond, and in the process, we're going to react it with hydrogen, palladium, and carbon. We are going to add, we already have one hydrogen. I think there's no hydrogen here. We have one here, none here. But we're going to basically add one hydrogen each to the carbon from this hydrogen. So this is the one coming from, I'm just going to put it in circles so you know. This hydrogen was already there. We've added one hydrogen each to each of the two carbons from the hydrogen in the reagent. So now we basically have an alkane, right? So essentially this was writing as I said, the bridge is basically two hydrogens and a substituent means one hydrogen. So you do not have to, if you have to just saw a simple line structure of this product, this is what it would look like. And as part of your my thoughts, I want you to name the compound. Now that's an alkane. So basically when you're given a molecule like this and you're given hydrogen, just write it without the double bond. Because what that means is you've added hydrogen to the system. Is there any difference between the two? No. Here I've shown you how it works. Here you just have to write it. You can ask me, hey, what if there's a OH or BR or anything in the system? It doesn't matter. This only is double bond exclusive. Okay. Okay, double bond exclusive. And if you want, yeah, I'll give you I don't think I need to give you a practice. This is good enough. Okay, just remember this, and I will see you with another video.